Okay, problem number 53, maximum subarray. This is a review. Since the problem yesterday, I think I should I want to review some of the related problems, and this include maximum subarray, and also there is a maximum product subarray. It's another problem, and yes, the problem yesterday is a subsequence, and this is for the subarray. It's for a subarray, and it is also like it wants us to find a subarray that is not an empty sequence of elements within an array. So yeah, it has to be at least one element in the array. Yeah, so it's kind of related to the problem yesterday. So yeah, I just want to go through it. And okay, the problem is that given an integer array nums, find the subarray with the largest sum and return its sum. And okay, so the array has negatives, positives, integers, and it has at least one element. Yeah, and so it can have 0 as well. And we cannot sort since it wants us to find a subarray that is a sequence. Okay, so for at least one element, this part, like, we had to put ourselves in the option, like so like when looking at the last element, there is two choices. Or sum, like, okay, so for having the largest sum, we would like to have positives, and keep finding a larger value. I'll say, so for when looking at the last element, there is two options. One is to combine to the previous sum, and the other is to start it by itself. Okay, so and we don't select this element, like yeah, so for element I, so if we are at element I, if select nums I, it can, like, there are two options. Okay, yeah, there are two options. One is to I'll say if select the last element, the problem will become okay, let's stay with the two options. If selecting the last nums I, one option is to like added with the previous sum, or started by itself, and we can, if no select, then the problem shrinks to finding the max sum in the previous array. In the rest of the array. So if we first do a recursion, and I will name this recursion function as that DFS, it's a depth first search. So I will have DFS I, and I represents the index of nums array. And okay, so DFS I will be defined as the maximum sum from the maximum sum from nums I, nums 0 to nums I. And for DFS I, it can be, like there are totals the 3 options. So it will be DFS I minus 1. This is if don't select. Then also there is if selecting, then it would be DFS I minus 1 plus the previous sum plus this current value. And also we can start by ourselves. So wait, but okay, we can say there is no select option. Then because if we don't select this element and then we select this and we don't select this, and so this is not a subarray, it will be a subsequence. So so we cannot do it like this. I think we should change to we should calculate every subarray, every subarray that ends at nums I, and then we will go through go through the answer at the end, like go through all the subarrays ending at 0 to I and see which one is the maximum. So yeah, if we change the definition, it will be, okay, so DFS I will be the maximum sum that ends at nums I. So for DFS I, it would be, yeah, there's no stack option, so it will be only added to the previous subarray or started by itself. Okay, so and this time complexity will be ON. Okay, let's start. So n, let's start with n is equal to the length of nums, and the DFS function will be I, and so let's do the boundary later. And for the other that is not in the boundaries, it will be return max between DFS I minus 1, the previous sum, plus nums I, or it's started with 0. And we will have the answer that is, okay, we should sum the DFS I for I in range n, and for the boundaries, that will be if I is smaller than 0, yeah, then we have nothing to select, so we will return I think maybe we can end, yeah, like end at when I is 0, then we will return nums 0, like nums I. Oh, Actually, oh, this is not sum, like this is maximum. Okay. And we will add a catch. And yeah, we can change it to a for loop. So it will be, yeah, we should first have a matrix. So we will have max sum equals like n let's have 0 and number of n zeros. So for I in range n, and I'll say we started from 1 since our default value will be the first element in the array. So max sum I will be the previous value plus itself, or started from itself. And we'll have to see who has the maximum value. Yeah, we can optimize this since this, like, it only depends on the previous value. So yeah, we can do like max. Yeah, we can do like max equals non-zero as a default, and we can change this. Oh, but yeah, we have to memorize all the oh, but we can have like answer is this, and we will have answer equals max let's see. Okay, so we can delete this, and yeah, okay, so far so good.